So you have to know the multiples. When you see a 7, you have to know 7, 14, 21, 28, 35, and on up, because you have to immediately see what that 6 and that 7 have in common. Or in this case, what that 5 and that 4 have in common. What's the first number that they can both be cut into?
20.
20th. I can cut a fifth. Once it's cut into 5 pieces, I can go back and cut each piece 4 times and get some 20ths here. I can also take the 4 and cut it 5 times and get some 20ths. So I know I can cut them both into 20ths. Okay? If it's a fourth, how many times do I have to cut each piece?
5.
5. So when I used to have 3 pieces, I'm going to now have 15 pieces, you see. Because each piece is going to become 5. The 5 I have to cut how many times to make 20? 4. So where I used to have 2 pieces, each piece is going to now be 4. So I'm going to have 8 pieces. Okay? The next step, Robert?
We had numerators.
Add or
Whole
subtract the
numbers.
numerators. Because, see, the good thing about it is that the same steps for adding are the same steps for subtracting. So it's not like you have to learn a new set of rules for each one of them: adding, subtracting, multiplying, and dividing. Adding and subtracting, same rules, except when you get to it, you're going to subtract them. If this was a subtraction sign here, I still would have written it vertically. I still would have gotten a common denominator. But now when I get here, now, of course, these wouldn't be a 2 and a 3, it would be a 3 and a 2, because I can do it, but I get a negative. But just looking at the fraction here, I had 15 of them, I gave you 8 of them, I just have 7 of them left, right? So you either add or subtract the numerator when you get to this point. Numerator, from the word number, it tells us how many. That's the top number. It makes sense because that tells us how many. It tells us the number of things you have is your numerator. And then the last thing you do in any of the processes is do what? Simplify or reduce your answer. To simplify means, you know, sometimes you end up, you only had 1/4, somebody else gave you 26/4. You know, just like you had 1/4, somebody can give you 26 quarters, you have 27 quarters in your hand. If you got 27 quarters, this tells us it only takes 4 pieces to make a whole. I got 27 pieces. That means every time I can take 4 pieces out, I can get another dollar if they were quarters, right? That's what you're looking at. That's what simplifying means. If I have more than enough to make a whole, I'm going to see how many wholes can I make. If I had 27 of them, I can make $6. Use up 24 of them, right? And I'd have 3 of those quarters still left. That's simplifying. Reducing is when we had 2/10 could change to 1/5. We make the group bigger, okay? That's when you can find what number can I pair them off into, what number can I divide by, you see, and that was the 2, okay? So in this case, so that's simplifying. Reducing is if I have 2/10 equals 1/5. Now I can tell you that anytime you ever have fraction problems on any test, it will be incorrect if they're not reduced. If you end up with 2/10 and you put that down as your answer, it'll be wrong. It's got to be 1/5. So a lot of times when you work problems and you may know I've worked it just right, but I can't find my answer there, it may be because you forgot to reduce and the answer there in the choice is reduced. So that's the first thing to check. Check to make sure you've reduced your answer to the lowest terms is what that's called. That means the biggest piece. So here we had 15 and we got 8 more. We have 23 of those 20ths. And we have 5 whole things. That's like having $5 and a bunch of change. That's what it means. See, when we have 4 quarters, we say we have $1. But you don't. You have the equivalent of $1. You can spend it like $1. But you have 4 of the things that it takes 4 of to make a whole. You don't really have $1 unless you have a dollar bill. Okay, so that's what this is. You have 5 whole things uncut. And then you have 23 pieces out of something that it only takes 20 pieces to make a whole. So I can make another whole right here, right? So that's like having $5 and enough change to have $1 and some change. See what I mean? So it should make sense. You see that happening. You could have a pizza party, and you get all kinds of pizza, and at the end you got these many pieces of this kind left, these many pieces of this kind left, these many pieces, and we always take them then and put them back in the box and make whole pizzas again. You've seen that happen, right? Even though they're all mixed up, it's still a whole equivalent to a whole pizza. It's not a whole pizza because it's cut, but it's equivalent to a whole pizza. Then you still might have some pieces left. And that's what happens here. I can take 20 pieces out, make another whole. I'd have 6 holes, and I'd still have 3 of those 20ths left. That make sense to everybody? Okay, we're gonna see if it did. Let you do some problems before we leave. And then the only other thing I want to show you is that subtraction just has one little quirk to it that people want to try to make hard. And it's not difficult when you understand what's going on. Okay, let's see. Turn to page 115. Let's see where the problems are. Actually, let's see, I'm gonna try and send it a little bit better for you. Oh, you need the, turn to page 117. Let's look at number 4 in exercise 9. Did you not find, are there no more? They're probably different ones, those are different ones. You can just share, you just gonna have to share. There should be more books unless people have all of them. There should have been 20. We should let you share. Do number 4 on 117. All 3 of those across. Yes. Follow those 4 steps. Number 4, straight across.
115?
117. Exercise 9. All 3 of those across 4. Number 4 has 3 problems. Okay, the first one, 5 6 plus 7 12. What was the common denominator?
12.
12, and what is your answer?
1 and 5 12.
So 17 twelfths is your initial answer, but that's an improper fraction, you have to simplify. You didn't do the last step. If you have 17 twelfths, how many twelfths does it take to make a whole?
12.
12, right? It takes 12 to make a whole, and you have 17 of them, you have a whole. Anytime you have the same number or a bigger number on the top, you have at least a whole, and you have to simplify it. So you're gonna take 12 out of that 17 and make yourself one whole, and you still have 5 of those 12ths left. So 1 and 5 twelfths, okay? And 2/3 and 3/4, what was the common denominator? 12 again, and what was your answer?
1 and 2/3.
Everyone?